Let's discuss X-linked recessive diseases. So these diseases are Bruton A gamma globulinemia, Duchenne and Becker muscular dystrophies, Fabry disease, G6PD deficiency, hemophilia A and B, Hunter syndrome, Lesch-Nyhan syndrome, ocular albinism, ornithine transcarbamylase or OTC deficiency, Wiskott-Eldridge syndrome. So these are main X-linked recessive diseases. Females with Turner syndrome or 45XO are more likely to have X-linked recessive disorder. So what is X inactivation or ionization or lionization? During development, one of the X chromosome in each XX cell is randomly deactivated and condensed into Bohr body, methylated heterochromatin. So it is inactivation of X is called ionization or lionization. If skewed inactivation occurs, XX individuals may express X-linked recessive disease. For example, G6PD penetrance and severity of X-linked dominant diseases in XX individuals may also be impacted. Now we will discuss about muscular dystrophies. Muscular dystrophies are Duchenne, Becker, Duchenne muscular dystrophy, Becker muscular dystrophy, and myotonic dystrophy. First, we will discuss about Duchenne muscular dystrophy. Duchenne muscular dystrophy, it is X-linked recessive. So X-linked recessive disorder, it is due to frame shift deletion or nonsense mutation. It is basically due to absent dystrophin protein. Progressive myofiber damage can also result from splicing errors. Weakness begins in pelvic girdle muscle and progressive spirally pseudohypertrophy of calf muscle due to fibrofatty replacement of muscle. So patient presents with paddling gait. Onset is before 5 years of age. Dilated cardiomyopathy is common cause of death in Duchenne muscular dystrophy. Gower sign is also present. Patient, the children is basically unable to wake up, unable to stand up with his own. He put his pressure on his legs and then he wake up. It is called Gower's signs. Patient uses upper extremities to help stand up. Classically seen in Duchenne muscular dystrophy, but also seen in other muscular dystrophies and inflammatory myopathies like polymyositis. Duchenne is equal to deleted dystrophin. Dystrophin gene or dystrophin gene, Duchenne muscular dystrophy is the largest protein coding human gene. It leads to increased chance of spontaneous mutation. Dystrophin helps to anchor muscle fiber to the extracellular matrix, primarily in skeletal and cardiac muscle. Loss of dystrophin, myonecrosis, increased CK and aldolase. It is also CK is increased in Duchenne muscular dystrophy, and aldolase also increase. So how we confirm Duchenne muscular dystrophy? By genetic testing. It confirms Duchenne muscular dystrophy. Becker muscular dystrophy. It is also X-linked recessive disorder, typically due to non-frame shift deletion. Duchenne was due to frame shift mutation or deletion of dystrophin, and Becker is non-frame shift deletion in dystrophin gene. Like it means dystrophin is not fully destroyed. It is present. It is partially functional and instead of truncated or destroyed. Becker is less severe than Duchenne. Becker is better. Onset is in teenage or early adulthood. Deletion of dystrophin can cause both Duchenne and Becker muscular dystrophies Two-thirds of cases have large deletions spanning one or more exons. Myotonic dystrophy. Myotonic dystrophy, it is autosomal dominant. Dystrophy and Becker muscular dystrophy, these are X-linked recessive, and myotonic dystrophy or MD, it is autosomal dominant. Onset is 20 to 30 years old. It is late onset. So which gene is impacted? CTG, trinucleotide repeat expansion in DMPK gene. So DMPK gene is very important. CTG repeat expansion in DMPK gene. So it leads to abnormal expression of myotonin protein kinase. That leads to percussion myotonia, for example, difficulty releasing hand from handshake, muscle wasting, cataract, testicular atrophy, frontal balding or atopia, arrhythmia. These are signs of myotonic dystrophy. Cataracts, topy, early balding in males, gonadal atrophy, muscle biopsy shows ring fibers and central nuclei. So these are classic signs of myotonic dystrophy. Its onset is 20 to 30 years age. It is in CTG trinucleotide repeat expansion in DMPK gene, and it presents with muscle wasting and difficulty handshake, muscle wasting, cataracts, testicular atrophy, and balding, arrhythmia. These are classic signs of this myotonic dystrophy, and it is also autosomal dominant disease.